Let us look at some more standard integrals. Integral of 1 by square root of a square minus x square dx is equal to sine inverse of x by a plus c. So again, differentiate the right hand side, and of course you should be knowing that sine inverse of x by a derivative is 1 by square root of 1 minus x by a squared times 1 by a plus 0. So now simplify this. This is x square by a square. So this expression becomes a square minus x square by a square. So square root of a square in the denominator comes out of the square root as 1 by a, and since it is 1 by a, it goes up. So we end up with a by square root of a square minus x square times 1 by a cancels, and we are left with 1 by square root of a square minus x square, which is what is there under the integral. Next one, integral of 1 by square root of x square minus a square. Here it was a square minus x square. Here it is x square minus a square dx is equal to natural log of absolute value of x plus square root of x square minus a square plus c. Again, differentiating the right hand side, we get 1 by x plus square root of x square minus a square times the derivative of x, that is 1, plus, now this we take it as x square minus a square to the power of 1 by 2. So when we differentiate it, we get 1 by 2 times x square minus a square to the power of 1 by 2 minus 1, which gives us minus 1 by 2 times the derivative of x square, which is 2x. Simplifying this, we get 1 by x plus square root of x square minus a square times 1 plus x by square root of x square minus a square. Simplified further by adding these two terms, we get square root of x square minus a square plus x divided by square root of x square minus a square times 1 by x plus square root of x square minus a square. So here, if you notice, numerator and denominator are same, so cancel out, and we have 1 by square root of x square minus a square, which is what is there under the integral. Okay, now next one. Integral of 1 by a square minus x square dx is equal to 1 by 2a natural log of a plus x by a minus x plus c. So differentiate it, the right hand side, we get 1 by 2a is a constant, so as it is, times the derivative of natural log of a plus x by a minus x, which will be its reciprocal. So a minus x by a plus x times the derivative of this term, a plus x by a minus x plus 0. Now here we apply the quotient rule. So a minus x times the derivative of the numerator, which is 1, minus a plus x as it is, and then the derivative of the denominator, which is minus 1. The whole thing divided by square, a minus x square. Simplify it. So when we simplify this expression, we get a minus x plus a plus x. X cancel out, and we have 2a. 2a cancel out, and one of the a minus x will cancel out. So we have 1 by a plus x times 1 by a minus x, which is equal to 1 by a square minus x square, which is what is there under the integral. Now the next one, integral of 1 by a square plus x square dx is equal to 1 by a tan inverse of x by a plus c. So again, same procedure, differentiate the right hand side, we get 1 by a constant as it is times a by a square plus x square. That is the derivative of tan inverse of x by a. A cancels and we are left with 1 by a square plus x square, which is there under the integral. Now, 18th one. Integral of 1 by absolute value of x times x square minus a square dx is equal to 1 by a sec inverse of x by a plus c. So differentiating the right hand side, we get 1 by a constant, so as it is, times sec inverse x by a derivative is a by absolute value of x times square root of x square minus a square plus 0. Simplifying it, a cancel out. So we have 1 by absolute value of x times square root of x square minus a square. So those were some standard integrals. Now here you have to remember certain points which I have not mentioned it explicitly with respect to all these integrals. So points to remember with respect to all these integrals, the denominator cannot be equal to 0. You have to make sure that you are clear about the absolute signs. And you should not end up with an expression evaluating to a square root of a negative number to avoid getting into the complex world. For example, here we have a square root. Now, inside this square root, x has to be greater than a to avoid getting into the complex world, to avoid getting a negative number under a square root. Another reason why we can't even have x equal to a. Why? Because this will evaluate to 0 and we will end up with division by 0. So x has to be greater than a, and also not only with respect to the square root but also with respect to this x inside the absolute sign, that cannot be equal to 0, because otherwise we again end up with division by 0. So these are a few points that you have to remember. Again, let me remind you, there is a link to a PDF book which describes all these in detail. Please feel free to download it, refer to it, and if you think somebody else can also benefit from it, please do share. That's it for now.